Let's take a moment to talk about intensive and extensive properties and how that comes into play for density. Okay, let's start with some quick definitions. Intensive properties do not change when the size of the sample changes. So let's give you an example. If we have a piece of yellow sulfur and I cut that piece in half, it's still yellow. And so I changed the size of the sample, but the property of color, it being yellow, stayed the same. So that would be an intensive property, color intensive property. Extensive properties do change with the size of the sample. And now an example of this, if I take the same piece of sulfur, I cut it in half, my mass is now half as much as what it used to be, and my volume is half as much of what it used to be. So mass and volume are extensive properties. They are properties that changed when we changed the size of the sample. Density can get confusing. Is it intensive or is it extensive? Well, we know that mass and volume are extensive properties, and density is how much mass is contained in a certain amount of volume for a substance. So we have two extensive properties that actually in fact result in an intensive property. But why would that be? How could I take two extensive properties and then end up with an intensive property of density? The reason why this happens is because it's the amount of mass per volume, and we have this very specific ratio between the two. If I take this mass of my sample, I take the sample and I cut it in half, now my mass is half as much and my volume is half as much, so we end up with the same ratio between the two, and the density is the same as it was before. This can go the other direction as well. If I double my sample size, my mass would be twice as much, but my volume would also be twice as much, so the ratio between the two would stay the same, and so the density would stay the same. It didn't matter when the sample was half as much or the sample was twice as much, the density remained the same, and that's what makes it an intensive property. Now let's look at an example of this. What if I have a piece of wood and I put it into a cup of water? It's going to float. And the reason why it floats is because the density of the wood is less than the density of the water. Now, if I take the piece of wood out and I cut it in half and I put it back in the water, it doesn't all of a sudden sink to the bottom. It still remains floating. And the reason why it's still floating is because the density didn't change, even though I changed the size of the sample. Now, if I take that piece of wood and I double it somehow, and I put that in the water, again, it's going to float because the density wasn't changed, but the size of the sample was changed. The other item that I wanted to address was classifications of matter. Okay, so you need to be able to look at different types of matter and be able to tell me if it's an element, a compound, a homogeneous mixture, or a heterogeneous mixture. Okay. But what's the difference between all these items? Well, let's look at the atoms and the molecules that they're composed of. Okay. Elements are made up of one type of atom. Okay, and so if you look at your periodic table, each of those elements are composed of atoms of just that type. So if this was the element of gold, every single one of these atoms would be a gold atom and there wouldn't be anything else in there. Okay. Now, compounds have more than one type of atom, but they're chemically bonded into a molecule. And you see the same molecule over and over again, and there's nothing else in there except for that same molecule. So like here is a good example of water. We have two hydrogens and one oxygen, and we have our water molecule, and then in this compound, it is only water molecules that make it up. And so that's what makes it a compound. Now on the other side of this, we have mixtures. Now mixtures have more than one type of item in them, meaning they're not chemically combined. See how this atom is not chemically combined to that molecule? Because they are different from one another and they're not chemically combined, it's a mixture. Now, mixtures can either be homogeneous or heterogeneous. Homogeneous mixtures are evenly mixed throughout. So our yellow atoms here are evenly distributed throughout this green molecule. In heterogeneous mixtures, there's a clear distinction. We're able to tell that all the water molecules are on top of whatever molecule is down here. We either have layers or chunks of the items. Okay? And so when you can see that distinction and it's not uniform throughout, that makes it a heterogeneous mixture.